Okay, in this video we're going to talk about basically the hybrid, if you will, transformations of the absolute values. So we talked about in the last videos about if you added a constant k, then the absolute value function shifted up and down. If you subtracted some constant h that was inside the absolute value bars, it shifted left or right, okay, depending on whether it was positive or negative. Now keep in mind, just like the linear functions, it was opposite. So we would have, if you subtracted 3, you moved that absolute value function to the right 3. If you subtracted a negative 3 or added 3, it moved to the left 3. Okay? And when you did a, when you multiply it by some coefficient a, then it either stretched vertically, shrunk vertically, or reflected over the x-axis. Okay, and it ended up, we found that all the linear transformations were the same as the absolute value transformations. Like, it didn't matter. Okay, so this one, it can also go off of PEMDAS. So I say parentheses, but I'm talking about the absolute value bars in this case. There's no exponents. And so let's start out. Okay, so we should have the absolute value, and I got 2 pencils, and I'm trying to make the absolute value function, which roughly looks like this. Okay, so that's my absolute value function. Okay, so if I do everything inside the absolute value bars first, it says add 3. That means we're going to shift over 3 units. So 1, 2, 3. Okay, and conveniently, this will actually, the graph will actually pass through 3 on the y-axis. That will be the y-intercept. Okay, so that's parentheses, if you will. Okay, or absolute value bars. Okay, the next thing is multiply by a, or in this case it's negative 2. So I'm going to split this just like I did in the linear video. Let's do the negative part first, and then we'll do the 2. So the negative we saw ended up flipping this thing across, reflecting it across the x-axis. And so when I reflect it, I should get this function right here. Okay? And it would pass through the y-intercept at negative 3. Okay? So that's the negative part. The multiplying it by 2 meant that the distance doubled. The distance doubled. So I should end up, let's see, if I double that distance, first of all, this is double 3 would make 6, and it should pass through a point about right here. Okay, and then the same thing on the other side. Double that distance, it makes 6. It might be about right there or so. And so this thing then kind of folds in. It stretches vertically. And you can see that each pencil is now parallel with the absolute value function here. Okay, the last part, so we just multiplied, and there's no dividing. The addition was inside the absolute value bars. Now we just need to subtract 1, which means that it's going to translate or shift 1 unit down. And we can see now that my absolute value function lies on the lines of the original function, of the purple function.